Today we will be working with this data visualization and exploration. And first data set that we will look at is donation, alumni donation that has come across from various batches who has passed previously, and how we can explore and find a, a correlation between or any pattern that is there in the that is there in between other variables and the amount of donation that has been donated. So you see, I have gender, I have class here, mental status, major, subject that they have passed with, if they have pursued next degree or not, the amount of donation that they have given, first, second, third, or so on, and actually they have attended the alumni meet or not. So this is the pattern of the data set that we have today. So let us look at the data and understand that what we can check from the data and what we can understand, and how the various techniques that we have will actually help us to understand what we can find out or how we can get the insights from the data. So let us start. So this is donation. This is the data set donation. I have named it Dawn, and this is my row and this is my column. So what will be the output of this command? Quite straightforward. Correct. First five rows and with all the columns. So here, as you see, I have gender, class, the year which they have passed out, marital status, and all the donation that they have provided so far, and if at all they have attended this session or not. So let us try to understand that how this classes or the year which they have passed out has been uh, distributed. So let us check that. So total observation that I have. So are you still facing issue with my audio or is it fine? So as you can see here, uh, I have a data set of 1230 observations. So these many number of rows that I have and 11 variables total. So from that, people from 57 batch have donated are this many numbers, this many number of students have passed out in this year, and so on. So I see that there is an increasing trend. So let us put that in a bar chart and try to understand. So bar chart is a part of lattice, and I need to install this now. So now it is done. So let us do that now. So you see here I have got the graph for the year 57. This was the trend, 67 and so on. Okay. So as you can see, this is the trend for all the class year that I have, and number of students that have passed from those years. So for 57 it is less, 67 more, 77 more, and keeps on increasing in a linear basis till 97. So so this was the trend. So this is about bar chart. So let us understand the code as well. So for bar chart, you need to define the variable for which you need the frequency. So mainly as we have of proc frequency, this actually creates the count for that number of layers and stores that in a table. And bar chart, for that, for bar chart you actually need to define provide a table. So it will take the information from the table and display. And you can also provide X label or column. So I don't have any Y label, so it is only frequency. Apart from that, if I remove this horizontal equal to false and then execute, so I'm getting like this. So any way you prefer, you can do that. It is entirely up to you. Fine. So one more thing regarding the data set. So I have donation in discrete years. That means for the year 2000, 2001, 2002, 2003, and 4. So how many people have donated? So I need to have information about the cumulative donation or the and the total donation that has been that has come from a student or an alumni. So for that, what I'm doing is I'm creating a new variable, total giving or T giving. So and it will add all my donation that has been made by an alumni, and I will make a sum of it. Let us check the mean of total donation. So it is somewhere around 980, and when you look at the standard deviation, it is quite high, quite more than what we would have expected. So that means somebody has donated quite less and someone has donated quite more or extremely more than the main value that I have. So there is some variation and we need to take care of that. So let us see what has been the variation of total givens according to the percentile. So here the code is quantile. Is actually quantile means quarterly distribution of my
Ankit,
uh, yeah. Yeah, who is this?
Ankit, can we use the sum function in the addition?
Yes, some function can also be used. So if you see, some function won't make much of a sense here because so this is my sum. But also I need to understand that these are my number of observation and uh, so so what has come from a particular individual that needs to be taken care of. So sum or any other transformation you can do or even median or another or any other function you can also apply. So here mainly what I was looking for that how the distribution of the donation looks like. For that I have taken a mean and a standard deviation. So what I'm doing now is I'm making a percentile wise distribution of my donation. So what has been the donation at 0 percentile? So sequence. So let me explain what sequence does. So this is S2 sequence and where I need to start, where I need to stop, and what would be my gap between all the ranges that I have. So see, I have it will start from 0, it will end at 1, and it will be a gap of 0.05. So 0, 0.05, zero point 0.10, and so on till 1. It is continued. So here also in quantile, I am checking that my total donation starting from the 0th percentile till the 100th percentile and with a gap of zero point 0.05 percentile. So let us check that. So you see here, if I enlarge it a bit, So for 0, I have 0, and 5 percentile 0, 10, 30, 40. So there are many people who haven't donated. Around 30% of the population hasn't donated. It starts from 35% or 35% of the population. It starts where they have donated something, and it is only 10 or 25 or such less quantity. Then now if I look at, so let me expand this a bit. So now if I look at from 50 percentile to 90 percentile, the amount of donation has gone up from 95. And when you compare the difference of 95 with 100, the difference is quite high, right? So that is the reason why standard deviation that we are getting is quite high, and that is not expected for a normal distribution. So obviously this doesn't show a normal curve or a normal distribution. It is quite the nature deviates from the normal. So let us see what are the transformation that can be done on the data. So here we have seen that from 95 to 100 percentile, we have seen a gap, a huge jump. So let us see how the distribution between 95 to 1 or 95 to 100 looks like. So when you look at the 95 percentile, 2277. It starts from there 3000, 5000, 7000, 16,000, and then 1 lakh, 1 lakh 71,000. So there is a huge jump here. So that could be the reason that my standard deviation has deviated so much, or it is so high compared to my mean. So yeah, so quantile is my percentile that I'm getting, percentile of my distribution. So my distribution is total donation that I have got. So the variable that I've just created, and from that I am providing a probability series. So probability is starting from 0, a probability, or I would say the percentile, the from starting from a percentile of 0 till 1 with a gap of 5 percentile, right? So this is how my distribution of this has been. Now suppose if I would have given only one thing, let's say props equal to 99, then it has given me the distribution only for the 99th percentile, not entirely. But here I require for all the distribution, or I should say for a series of distribution with a given uh, gap, with a specified gap. For that I have used this sequence function. Okay, so few are having some queries. Okay, yeah. So SAS equivalent I'm currently not so sure about. I think in proc frequency we can arrange that according to the percentile.
Ankit, just one thing.
Yeah.
Ankit, just one thing. So every time we need to, like, suppose if you want to identify the quantile, so
Hmm.
we need to define it under sequence itself only, right?
Yeah.
No, out of sequence we can't define it, right?
Yeah. So one thing can be done. Sequence actually produces a series of length or series of vector. So
Right.
if you can type it manually without providing sequence, it is up to you. Either you can do it manually or you can provide a function which will actually do that.
Okay. Right.
So, like I showed just now, that if I need
Okay.
only for
Okay.
one uh, percentile, I can type that and I can get that. But for here, I need to see how the series has been or have been, you know, getting affected, or how is the distribution towards the late end of the variable. So, if someone is not speaking, please go on.
Okay. So basically, it is giving in a particular interval.
Correct, correct, correct.
Okay, thank you.
Okay. So, Vimal, I didn't get you. So, okay. So, let us understand histogram. So, histogram is also a part of lattice package. So, histogram, I think, so quantile mainly you require when you have some distribution. So, it could be any distribution. So, mainly when you have a continuous distribution, like for example, here. So, here you won't need a quantile because I have specific range or specific category of years only. It is not a continuous variable, but donation could be any amount. It could be 10 rupees, 100 rupees, or anything more than that. So it could be any amount and can take any value. So for that reason, I need to see how it is varying. So just to give you one more example, that plot density. So let me show you this. So when you see this and density, you can actually understand that most of the people haven't donated anything because it is close to zero. After that, they have donated some amount here. There is something here. So this is quite minute, very less. So this density plot actually shows me that most of the people haven't donated anything. Only some donation towards the end, some high amount. And that is what was evident from my quantile plot, that around 30% of the population haven't donated anything. It starts from 35% of the population that they have donated something, or it could be even in between 30 to 35 as well. So these steps are quite required because you need to understand your data and how it has been, you know, spaced in the or how it has been distributed. So these things that you need to understand uh, from your data, and then you need to apply some of the technique that we will study later on. So let us see histogram as well, and in histogram also I'm expecting that most of the population will be near to zero, and as expected, most of the population is near to zero, hardly anything away. So here is some a small bar here that is also quite faint. Uh, Let us do with histogram package and lattice, and let us see what would be my result. So see, so lattice package mainly shows the result in a much more or much convenient way or more in a user friendly way compared to the base R package that I have. And here I can see much more detail or a better analysis. Okay, so this is the reason, and lattice package is quite useful when you are dealing with data visualization or to understand how the data has been distributed. That is quite useful for that. So this was still plot, and density plot is also a part of package. So density plot, as you can see, it is part of a lattice package. And the plot which I did earlier, plot and then bracket density, then the variable name, that was part of base R package, or it is there in base R. So now let me give my variable name. So here it also provides a dot. So for number of population that are near to zero, it has provided so many dots. And as my number of population decreases, as I increase the number of the amount of donation that has been generated from alumni, so it reduces. So most of my population is concentrated near to zero, as it is evident. So here I'm.
What kind of data we go for a density plot?
What kind of data we go for?
Density plot.
So mainly a continuous variable. So so if I ask you, I have so many variables. So for which one you choose a density plot and for which you don't? Can you please explain? So suppose I have a total donation for the year 2000 and so on, and class of the year. So which all would I go for a density plot and for which I won't? So you can try at least. Uh,
Okay.
so and this question is not as hard as it's in. Most of you are not responding, but anyway, so all you need to look at is if it is a continuous variable. So, like for example, for class of the year, this is numeric, but at the same time, it has some level that the class can be. It has to be discrete. It can be only 57, 58, or a year. But here I have a continuous variable. It can take any value. So the donation that has been provided is a continuous variable. So only requirement is uh, that your variable needs to be continuous. If that is the case, that then you can make a density plot. Otherwise, it won't make any sense. So let us what we have seen in the quantile is that most of the population is near to zero or less than 1,000. So as you have seen here as well, most of the population is way below 1,000 or near to zero. So let us subset the data and let us work with only that part which is less than 1,000. Now let us understand. So I'm subsetting the data. So I'm here subsetting the data, and now I'm trying to understand that how my histogram looks like. So here if you see, so with all the population are linked to zero, but at the same time there are I'm getting some insights or I'm able to understand it better. Otherwise, in the previous plot, I've seen that there is a big spike near zero, but apart from that, there is nothing clear. But when I subset my data, I'm able to understand or comprehend it better. So for that reason, when you see the standard deviation is quite high, you need to subset your data or need to understand that point out your mean, and uh, within the range of mean, you need to check that how your distribution has been or how your population has been distributed. So another, let us see the histogram. So this is the same command only, but with a different style. So both are same. So if you are finding the upper one more hard or difficult to comprehend, this is the easier equivalent of previous command. So let us have a box plot and just understand. So box plot also, if you see, most of the population is near to zero, and there are some population outside. So everything has been concentrated here only. So now, if again if I uh, check and if I change the orientation and see by so here again by substituting the data and limiting it only to 1000, if I see I am able to comprehend it better. Now here I'm doing is I'm subsetting my data, and with all the donation less than 30,000, less than or equal to 30,000, I'm storing it in another data set, and let us work with that data set. Okay, so let me repeat that part again. So here I have seen the box plot of the entire population. So now if you see, now if you compare, so what I've done is I've made a partition in the plot. Half of the plot will be for my one of my visualization, another will be for another visualization. So here I've made a complete plot of the entire distribution, and here I've subset my data and restricted it only till 1000. So here I'm able to comprehend it better. I'm able to understand it better, and it shows me that most of the population, that here is my mean value, and it is quite near to zero, less than 200 and near to zero, and it moves on to the higher part. So this is only about this box plot. So let us now subset the data and try to understand with the remaining part. So outline equal to false. Here it mainly for this outline equal to false. So let us now subset the data and understand. Correct, 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 Karshu. So let us now order the donation that I have received and decreasing equal to true. That means in descending order. Here what I have done is I have only selected few of the columns, not all the columns. So column from 1 to 5 and 12th. So 12th is my total given, and 1 to 5 is my gender, class, marital status, history, and next degree. So I've removed all the individual years of donation. Now let us order it and now try to understand. So here I am making a box plot of total given comparatively with each and every year. So year of passing out and the donation that has come from that batch. So for 1957, I have received the maximum donation, and it is quite likely also. Why? Because there is a reason to it. The reason being, if I am more senior and I have earned a lot, suppose my age is somewhere around 60, and I have a lot of money with me, so I would be having larger ability to donate compared to someone who has just recently passed out. So that trend can be seen here. So the mean for 57 population is quite high. Then with every subsequent batch, it goes down. And also the larger limit for batch 57 is quite high. So you see, there is a relation between the batch which the person has passed out with
I
the donation that
I
has come.
What does the dark, black line denote in
This
this?
shows mean.
Sorry,
I think this shows mean value.
main.
Mean or I think
yeah,
it was
this
median. Mean.
I think this is the IQR interquartile range, I guess.
Interquartile range
Because
is for
I
entire. So interquartile range stands for this entire box, I think, and this is
Yeah,
for median. I remember, if I'm correct.
median, right?
Median, right? Yeah, the
Okay,
middle value.
okay. Thanks.
Okay. So, and accordingly, with gender, if I say, so with gender, male have contributed more with compared to female, and also the uh, top length or the maximum contribution that has come from a male is higher compared to a female.
Ankit, so what does that dotted line denotes?
So this is actually the interquartile range. I remember, if I remember correctly. This is the interquartile range. Uh, how much is that range? Even I have to check on that, and because this was something even I keep on forgetting because I remember I've heard about 1.5 of the interquartile range that this denotes. So regarding Bloch's plot, what is the exact range or what is the exact value? I will let you know. I'll forward a document regarding that.
Hi
But
Ankit,
overall,
Arun this
mainly
side. Can
to
you hear me?
yeah, yeah,
Ankit, can I explain this box plot if you
yeah,
don't
please,
mind?
yeah, please, please. Yeah, please, Arun.
Can you please open that and zoom that image, please?
Mhm.
Okay, so the dotted line is actually means is that like after the Q3 or you can say P75
Mhm.
quartile.
Mhm.
So what is actually it actually check for the outliers like most of the outliers are actually comes after 3 sigma, okay, and
Mhm.
these dotted lines are actually called whiskers, okay. These are called the hands on of the particular box plot. So anything comes after that particular line that can be treated as your outliers.
Yeah.
So which means the horizontal line at the top, that is the denoting as an outlier. So whatever the data point falls near, I mean over there,
Beyond
those
that.
are outlier.
Mhm.
Yes, this is beyond after that line, it can be treated as your outliers.
Yeah.
Okay, and that line basically the dotted line will be the data points which are mostly falling into that particular period.
Yes, like this is the your anticipated range that this is not a quite specific that you have, but you may change it according to your data. But overall significance is there, like till now 1.5 sigma you can treat it as the hands of this box plot as a total line.
Okay. Thanks,
Okay.
Arun. So I remember this entire range was 1.5 sigma, correct?
Yes, yes, this is 1.5 sigma.
Okay, and this part was still 3 sigma or might 75th percentile.
Yes, this is Q3, and then the black line is median, and the
Ah,
lowest bottom line is your P1, or you can say first quintile.
yeah, correct. So this is mainly by
Why
25
does that
percentile,
they
50 percentile, and 75 percentile. And this is
Yes,
point 1.5 IQR into quartile range.
yes.
Okay.
and why does that they are made at this box? I mean, is there any meaning for that to make a particular box, or just to denote the box plot because of that they have made like this way?
No, no. Actually, the main scenario of the box plot is that to see in the real time cases, it is used to see if there is any outliers are present in our data part. Like without just taking a look at the variable values, we are not able to see. But after plotting the box plot, you can able to see like
Hello,
if there.
hello.
Yeah.
Yes.
I guess data set, okay, which has been used to see the observations and the analysis. So data presents the set of the observations, which has to be considered under the observation.
Like same I'm trying to say is that like
Yeah,
if you
correct.
have a continuous observation, you cannot figure it out by just taking a look at it, just open it. So if you plot a box plot to regarding that particular variable, it will show you that how is the trends is going on, like how it is a median
Perfect.
value. Okay.
Yeah, thank you.
Okay,
Okay.
thank you.
uh, okay, Ankit, so you may please proceed.
Okay. Thanks, Arun. So thanks for that explanation. So also let us now proceed with the marital status, and let us understand that what is there any relation between total donation and the marital status? So here also, as you can see, for widowed, my amount of donation or the median that I have is quite high compared to other categories. So there could be a reason for it. So if a person is aged or he has moved towards the age of retirement, it is quite likely that he would be a widow or widower. So for that reason, and also we have seen that most senior batchmates have made the largest contribution. So this could be the reason that most of my widowed or widower are uh, in the range of my highest donors, and least is from single, because if you are a recent pass out from a batch, and then you are expected to earn less compared to other uh, alumni. So for that reason, for most of the singles, we can see that the amount of donation that has come from them is quite less compared to other categories. And also let us check, is there any relation between the attendance of alumni meet with the total donation that has come. So here also you see, if a person has attended the alumni meeting, then the chances are quite high that he has made a donation compared to one who has not attended the meeting at all. So now let us make some more transformation, and let us understand. So here what I am doing is, according to the total donation that has come. So this is my numeric variable. As I have explained earlier, for pre-apply, my numeric variable and the major or the subject that the person has studied. In that, institute. So on basis of that, let me have a table and let me see is there any relation between the amount of donation that I have and the stream that the person has pursued. So here you see all the numbers are there that for American studies and anthropology, art, chemistry, zoology, education, economics. So also let us have a order of these numbers and let us represent it in some other format as well. So for all the majors that I have, so these are the number of students that have passed out from these departments. Now let us combine that and select only those where I see the value is more than 10 or the number of students that have passed out is more than 10. And now let us try to understand. So here if you see, so the main donation that has come from a business, economic business is highest and the number of students that were there is 24. So similarly, I have sorted down all the departments from them from which the highest donation has come, and the prerequisite for that is my number of students has to be more than 10. So specifically, if you see the economic business has made the highest donation compared to other departments. So there is a relation between the department of that person and also the amount of donation that has come. Now let us have a bar chart of this data that we have just created and only on the basis of this. So here I have taken only one or first column that means this. So this is my first column only. So on the basis of this I am making a bar chart. So again business economic business has the highest contribution, mean contribution and less for other departments, quite less or comparatively quite high for business economics when compared to other departments. And now let us try to understand if a person pursues uh, master degrees or next degree after his current education, is there any relation between his donation? So same thing we will do here as well. So we will subset the uh, data on the basis of number of students that were there in the department and the same criteria that it has to be more than 10. So let us do that and try to explore. So here if I see if they have pursued MBA, then the donation has come highest. The highest donation is from the MBA batch if next degree is MBA. Then JD, then MS, MD and so on. So also there is a relation between if a person has pursued a next degree or not. Now let us plot that the data that we have obtained just now. So again if you see the same thing or it's the same thing, it is just a graphical representation of that. Now again if you want to change the orientation, you can change horizontal equal to true or false depending upon the requirement that you have. So this was all about the relation between the categories and the amount of donation that has come. So let us do a few more things. So now here what I'm trying to do is my total donation as a part of every year. So for which year my density would be more. So let us see that. So here density plot has a better feature compared to the base R package. So if I try to explain him, so here what I am doing is a total donation that has come with factors. So factor of classes. That means for every year I will get a different, uh, I would say the density plot for every year. It will be segregated by every year. And here the criteria that I have said that the donation has to be uh, less than or equal to 1000 or more than 0. So starting from 0 to 1000, and the donation has to be a bit significant one. So it cannot be 0, it has to be greater than 0. So here if you see, so the most recent batch that has passed out, 97, so most of their density or the population that they have is concentrated near to 0. So here most of the population hasn't donated at all. Comparatively, when you go to 57, and there is something less in 0, and it increases actually after 0. So there is some donation from their side, and slowly it goes down. Then again for 67, 77, 87 also near to 0, but still a significant one. But 97, most of the population is near to 0. So here also you can see my maximum donation has come from a 57 batch and comparatively lower from other batches. Now let us look at some other plots as well. So I'm again making a transformation. So on the basis of donation and the class. So tree apply I have explained earlier. So this will be my numeric variable, and this will be my category or class on the basis of which I am making my segregation. So this is the sum that I have collected from 57 batch, then 67, and slowly it reduces down to 97 at least. So here if we see maximum donation from 57, then it goes down. Now if I'm making a year-wise analysis of what has been the contribution for specific year, let us try to do that and understand. So for 2004, let us see. So 57 batch is less, but 67 has made a larger contribution that year. Then slowly it goes down. So here I'm making a year-wise prediction or year-wise analysis, not prediction actually. Now for 2003, 57
Ankit,
batch.
can you just enlarge the code editor?
Okay.
Like yesterday, you had explained like it's a more or less equivalent to pivot, right? So
Yeah.
here you are just filtering it like for year level. You can filter it, right?
No, so no, I'm not filtering actually. So I already have a column for year-wise donation. So I'm making a pivot on
Yeah,
basis of this. So this is how.
you're plotting.
Yeah. So
I mean, we can just imagine it like you're just changing a filter of a pivot and creating a bar chart out of that pivot result, right?
correct. Absolutely correct.
Okay, thanks.
So here a few things that so y limit is actually the limit that you have set for your y plot. Similarly, you can have a x plot as well, but x plot here won't mean anything because I know that it is such uh, bar plot only, and I have only specific categories here in the x-axis. So y plot makes sense here, and also color and horizontal equal to true or false. You can set that. Now applying that now tree apply part here. Let me explain the pivot part. So this is my numeric variable that the donation that has come from 2014 batch on the basis of class. So class is my the year of passing out. So on basis of that, I am making a pivot. and from that pivot I'm making a bar chart. So this is what this entire code is doing. Okay, so let me go to 2002 batch and understand. So lesser trend. So here almost they have some equal contribution, but again lesser for 97 batch. Similarly for 2001 batch, if I so maximum contribution for 57, and slowly it goes down. Again for 2000 batch, some similar trend. So this is what I'm getting here. So this was all about this analysis of this mm, data. So one more thing that I want to talk about here is mosaic plot. So this is also one of the very good plot or visualization technique that we have. So here I have lot of categories. So here it hasn't filtered out any one of them, and so that's why I can see so many names, and one in between has been omitted out. So though it has been sorted in ascending order, uh, yeah, in alphabetical order, starting from A till C, but still the one in the middle has been omitted out because just to save the crisis of the space. So right, so regarding mosaic plot, let me go to that and explain. So mosaic plot is mainly it actually share of percentage. If you say variables of unequal length, so just so here let us look at some other plots as well. So here uh, total donation and on the basis of classes that I have. I don't understand why it's not accepting it. So here is a new dataset on Toyota cars. So let us view that and understand that what is the dataset and how it looks like. So here I've already loaded the Toyota dataset, and here I have price of a car, uh, age, how many kilometers it has covered, fuel type, horsepower, matte color or not. So it is actually shows that it has a metallic color or not. So metallic color, you can understand that it mainly gives you the color framework how it looks like. So automatic could be the part of on gear, whether it has an automatic gear or not. So this will be again level 1 or 0, how many cc car, how many doors and weight. So this is my data set, and let us understand that how it, so what we can extract from the data set using the same code and command that we have done so far. So Toyota, only the first 3 rows I have taken so far to understand and check. And now let us see the summary of Toyota. So here the price varies from 4,350 to the maximum price of 32,500. Age is minimum of 1 and maximum of 8 day. Kilometers minimum of 1 and maximum till 2,43,000 and so on. Fuel type, it is showing me only these 3 factors. So it is quite evident that my fuel type has been already designated as factor. So these are the factors that I have: CNG, diesel, and petrol. Horsepower again is a numeric, and all others, as you can see, this is numeric. So this needs to be a Met color needs to be a factor 1 because I know that I only have 1 or 0, nothing in between. So taking a quartile or median or mean won't help. So as you see, median is 1, so there is no between value of 0 and 1. Automatic also the same thing, median is 0, so only I have a 0 or 1 here. CC is my continuous variable. Doors are also discrete, either a discrete value or an integer, and weight is my continuous one. So let us understand what is the price. So histogram of price, let us see, and here you see how it has been distributed. So here what we are doing is we are making a flag variable here. So if the fuel type is 1, so one thing that you need to understand here, that flagging, how many flagging needs to be done. For example, if I have a factor variable with n levels, then how many factor variable or the flag variable I need to create?
It
Anyone?
depends upon the type of cars.
No, so I have already said that it is n levels. So n different categories that I have.
Okay.
So only one rule, that it needs to be n minus 1. So let's say another example. I have a factor of gender, and gender has 2 levels. So how many flag variable I need to create? Flag variable or dummy variable, that needs to be only 1. Why? Because if I know that uh, there could be only two cases, either the person is a male or a female. So 1 would be for male or vice versa, and 0 could be for female or vice versa. So here what happens is, when I'm capturing the data, for suppose if it is CNG, then this will be 1 and this will be 0. And if this is 0, diesel is also 0, then it is already, I'm quite sure about that my type of the fuel will be petrol, because both of them are 0, right? So this is how it is. So if I have n levels, then n minus 1 that I need to create. So let us create that. So Toyota fuel type. So fuel type 1, that is for diesel, all of them are 0, and diesel I have flagged it 1. For petrol, this is 0, this is 0. So it becomes a mirror image. So I'm sure that it is my other type, not the one which has been listed or which has been flagged. So let us drop one of the table and one of the column and then see. So here the fourth one.
Ankit,
Yeah.
can you explain this flag variable again? I mean, that understood that, okay, we need to create n minus 1. But in the example,
Mm-hmm.
we have created two columns, right, for CNG and for diesel.
Mm-hmm.
So, I mean, fuel type 1 and fuel type 2.
Correct. Yeah. So see,
So, just
fuel
wanted to
type.
understand. Yeah.
So fuel type here, I have only three factors: CNG, diesel, and petrol. Correct. And uh, so for three, I need to create two flags. Same thing I have done with the dataset here as well. I have created only two flags. one for CNG and one for diesel. And if it is not both of them, then it will be the other one. So if both are 0, then I am quite sure that it will be my petrol, right? So this is how this flagging is done.
Yes.
So any doubt?
Okay. Okay.
Okay, fine. So let us see some
Nice
plots
one.
of price and age. Is there any variation with price and age of the car? So this is how it looks like, but it's all scattered and it doesn't give me a good feeling that how it looks like. So let us have a different plot and let us understand. So there is something called scatter plot or smooth scatter plot. Smooth scatter, and there I can do price, sorry,
Wonderful things.
price with age and data equal to auto price not found. So this is my smooth scatter plot. So mainly I've got so many warning because there could be some missing values or some other issues. So in smooth scatter plot, I can see that most of my population are dense towards this side, and there is a negative relation between my price and age. So as the age increases, the price of the car also goes down. So though this is a bit hazy one, but it gives a clear understanding that how my data varies. So for some of the cases, I prefer smooth scatter plot over my normal plot. So let us check for kilometer and price as well. So again, some negative type of correlation, but it varies somewhat like exponentially, it goes down. So let us do same thing for here as well with the price in kilometer, and let us check how the smooth scatter plot looks like. So again, most of my population is concentrated here only. Though there is a variation, it starts from this and it goes down like this. But most of them are concentrated here. And here also I see a negative correlation between them. That as, as the kilometer increases, the price goes down. Though not a completely linear one, as linear as of age, but still a negative one. Again with horsepower, if I see. So horsepower here is discrete. So in discrete numbers, I have. So for that reason, it won't make much of a sense. Let me do that for horsepower as well, and let us see. So here also, so I can conclude that most of my vehicles have horsepower of somewhere around 110. Few of them here, but I don't see anything specific as a correlation or something like that here in my graph or the visualization or the plot that I've got. So nothing specific that I get here. Only thing is that the most of the my population are concentrated here. Again, discrete numbers, either I have 0 or 1. So there is something called jitter plot for this. So jitter plot I will explain some other day. Or what I can do is a better understanding here would have been to make a table. So table of price with met color. So even this is quite discrete, but yeah. And another thing that could have been done is density plot of both of them together. Density plot of auto and price with respect to my auto met color. So here I have for two levels, one is for 1 and one is for 0. So here if I mention it as a factor, so here it shows me for 0 and 1. So nothing much of a variation that I can see. Only thing is that it is more concentrated here and the peak is higher compared to this one. So all this I can see, nothing apart from this. A smooth scatter plot is mainly smoothing, or so what happens is when all your points are concentrated at some location, or specifically at some part of your graph, so that becomes quite hazy. Smooth scatter plot, what it does is it actually makes the density, or how closely these points are plotted in the graph. On basis of that, it makes a plot. So for suppose if most number of plots are located in a specific point, then that part will become darker or deeper compared to other points. And for suppose if some less points are located at a location, then that will become lighter. So that is mainly scatter plot. Smooth scatter plot is mainly gives me the density, or how many points are located in that location, depending upon the contrast of the color. Okay, so let us have a price with CC and understand. So here again a discrete one, so nothing uh, can be concluded from here. Even a smooth scatter plot won't help. So only thing that we can do is we can have a density plot of this, and then we can understand that how it has been distributed. So here, if I do a density plot, this is, and instead of met color, I'm doing it CC. CC as factor. So here also 1600 cc or 1800 cc, but again it doesn't make much of a sense. Also because the number of when I have made so many levels, the number of population for each of the level has gone down, and for that reason I'm not giving a good plot here. Now let us check is there any relation between price and doors. So again nothing, also because this is a discrete one. So few things here to call out that uh, if I have a discrete number here and if I have a continuous number here, then making a plot won't be a good idea. So uh, try to categorize your or try to understand your variable. If a variable is a categoric one and here we have a continuous one, then making a scatter plot is not a good option. Either try for density plot or try for a table that will list out the population for different levels. or have a pivot table. So as I said, a tree apply has a pivot equivalent in R. So that can be used to actually summarize the data or understand that how it has been related. So this is a regression line mainly. So we will talk about this later. So this was about a small data set of Toyota and how we can deal with it and how we can understand. The reason that I have made this flag of fuel type of 0 and 1 because that would be required in regression. So for that reason I've made it flag. The regression we will be doing some other day. So till today it was here only till understanding of the data. So let us move to one other uh, data set. So this was about orange juice that we have done yesterday. So this will be the last data set for the day. So things are already in place. So let us explore the data. So orange juice I have done yesterday also. So no need to explain about the data set and what are the factors or the variables that I have there. So I will move into the data visualization part. So all the stores, so if you remember, we had three stores yesterday: Dominic, Tropicana, and Minute Maid. So these were the three stores. Sorry, these were not the stores; these were the brand. So stores were actually the store number that we had, and these are also discrete in nature. So we will cast this as a factor and then proceed. So this was the mainly store number. A store number are also not a continuous number but are factors. So number here actually signifies that with which designation or which number it could be specified. So now let us do a tree apply and understand. So log move is one of my numeric variable and I want to aggregate on a basis of brand. So now let us do that on the basis of brand and week both. So here if you see for the 40th week Dominic, the log move for all of them is so, and for 41st week it is so. So it is also a good uh, way to understand. So that how it has varied. So a bar chart or a bar equivalent you can take, but the number of data here would be quite long, quite large comparatively. So here making a bar plot would be less helpful and more tedious or make the things more complicated compared or rather than simplifying it. So let us have a just linear plot of all the terms. So here what I'm doing is I'm taking only for Dominic and trying to understand that how it has varied from week to week. For first week, what was the log move value, then so on. So here if we see the value of log move has varied from starting from 0th week till the last week, how the value has varied, and the range is only from somewhere 7 to 12. Similarly, for we have done for Dominic, let us do that for Minute Maid and Tropicana as well. So one more thing, so there is another tool as well which can be used to see all these graphs all at the same time. So there is something called path. Then in that MF row equal to combination of how I want to say it. So mainly I want it to one edit on the top of the other. So I made one column and three rows. So it will be like three rows and one column. So once I do that, now let's see what happens. Okay. So to have a comparison with all of them, this is actually a good way to represent. So for Dominic, as I can see the variation, same thing for Minute Maid and Tropicana, and I can have a comparison or a comparative study for all the three at the same time. So here for this, what I did it, this is a command to section out your plot part or the space that you have for plot. You can section it out. So here what I did, number of rows is 3 and column is 1. So one column and 3 rows. So I made one at the top of the other to make a comparison. Now I want again to,
Did you?
yeah.
So I mean, what's the role of MF row variable over here? I mean,
So
it works as a table or something.
yeah. So mainly for making your plot section into different section or plot part. If suppose this is the entire area where you will see all your plots, so you can only see one at the same time. So having or to include two or three or multiple graphs in the same area, for that you need to do this mf row.
If
So
you just alter these values like 1, 3,
hmm,
then these three graphs would be
side by
displayed
side,
side by side,
yeah,
correct?
side by side. So if I do that,
Okay. Oh,
so this is
just
how it
sorry.
is. Mhm.
Okay, I got it. Okay, thanks.
So for that reason, I have done it on one on top of the other. And here also it was showing that margin, figure margin are too large. So actually it was like this small. So it is showing this error. So for that I have need to change this. So anyway, so here I have done is I have made a factors of all the brand on the basis of 1, 2, and 3. So I'm only showing that one for my first brand, second, and third, and I have repeated it so many times depending upon the number of week data that we have. And on basis of this, we will make a plot. And now I'm combining all of these. Now let's make a plot. So XY plot is part of my lattice dataset, lattice package actually. So in lattice, you will find this. But apart from that, if you want to do it individually, par MF row can work. But the lattice itself or XY plot has itself quite intelligent working, so it will arrange it automatically. So let me mention it out here as a part of package. Now here again, if I look at the box plot for log move with respect to brand that I have, so sorry, let me change it to 1 1, but otherwise it will again show it. So 1 1 means the entire plot will have only one plot. So one row, one column. So now it has entirely occupied the area. So there is not much difference. So the median value here is almost the same. Only there is a bit of variation in the highest or the lowest value in the outlier. For histogram, let us see. So here layout I have mentioned it like this. If I want to change the layout and do it like 3 comma 1, I can have it like this as well. So it is entirely up to me. So okay, so it is entirely up to you what you want to what you prefer. Similarly for density plot here, so more or less in the same way they are distributed. Now here what has happened is I've superimposed all of them at the same time. So point plot I have put it as false, and here I mentioned the groups. So one will represent one group and another will represent the other group. So uh, there is a feature in density plot through which you can do that. So if I mention a pipeline here or some like or sign here, so it will be segregated on the basis of brand. So different graph for different brand. But here if I make it groups, so everything in the same graph but with different group. Now XY plot on the basis of these.
So
Yeah.
Ankit, just write the comment over there so just to understand, when
Okay.
we go through the
Okay.
code.
Okay. Sure.
If- Thank you.
So here if I have so this or sign, and this will on the basis of my brand or basis of classification, and here all at the same time, the same graph. So mainly here I'm grouping them. So this is XY plot if I have not mentioned anything. So again this looks very ugly. So this also looks very ugly, and for that reason we have used this smooth scatter plot later. So let us look at some other data as well. Again, so nothing can be interpreted from here, and for this as well. So here that for that reason we use a smooth scatter plot to have a fair bit of understanding how variation is happening. So here at least I can have a slight understanding that for the denser part, if I consider, it is varying somewhere like this. So here I have somewhat a bit of understanding of my variation with these two variables. But otherwise, if I consider only for XY plot, uh, it was as good as nothing. So here if I see, I'm plotting log move, groups is feature. So in the same graph, different density plots. So there are two features, and depending on the features, this log move has been plotted. So for XY plot also, I have a option of groups. So this groups option is there for almost all the lattice related or lattice associated functions. So XY plot, density plot, or not scatter plot but histogram. So these are part of lattice package. So here you have that option of group or grouping them together. So let me mention it here. So here what I'm doing is, let us analyze only for store number 5, or where the store number 5, for that, for them only we will see how it looks like. So XY plot, as we have seen earlier, variation of different brands with each other. And then now if we look at price and log move, so again nothing can be same. And now if I segregate on the basis of brand and then check, so nothing, but if I do it on the basis of density plot and then group it according to the feature, so now here I can understand something, that for one feature how is the distribution, and for another feature how is the distribution. So for all of them, one feature has a similar sort of, or has a lesser value for log move. Other feature has higher value in the log move part. So this actually helps to make a good comparison between the two. Again, scatter plot doesn't help much. So let us now understand income with store, the store number that we have. So store number with each of the income with each of the store number. So to reapply here, as I said earlier, this is my numeric variable, and on what class or basis I want to segregate them, and what would be my function. So let me make so here what I'm doing is I'm making a comparison with maximum value and minimum value. So maximum score, or maximum that I'm getting log move or income value, average income is 11.23, and minimum income value is 9.86. So here what I'm doing is I'm taking out store number 62. Here I'm taking out store number 75, and I am combining it horizontally. So row bind, R bind stands for row bind. So if I have a data set at the top and I want to append it at the bottom, so it is similar to a append function in SAS. So, and it will join horizontally. So good thing about this is that my top part of the dataset will only contain 62, and bottom part will contain only 75. If I would have done like uh, 62 or 75, then it would have been all together. But it has made a segregation. Now XY plot. So let us do it only for these two stores and understand. So this is how it looks like, and let us do it on the basis of store with different groups feature. So this gives us a good idea. So for all the red one, they are towards the upper side of the graph, or having a higher log move value here as well. So for most of this, at least for these two stores, I can see that the log move value is on the higher side here as well, and for this feature it is on the lower side. Same thing that we have seen in the uh, density plot as well. That feature has a does make some distinguish between the log move values, and it does influence the log move value. So this is all for today. This was all about this analysis. So there are also many other packages in R for data analysis and mainly for visualization. One is ggplot2. So for all of you, you will this will be a part of your home assignment, or you can say as a task, that search on ggplot2. So I will give you a template which contains all the cheat code for, or all the code for ggplot2 that you need to understand. So I will give you that. Just do some R&D on that ggplot, because in few of the cases we will be dealing with ggplot and you need to understand on that. Here lattice, I have only worked with lattice, but ggplot is also a very good package to understand and work with. So for all of you, go through these packages and have some understanding of ggplot2. This will be the only thing that I'm expecting from you all. So that's all from my end. So anything if you want to ask, you can. Otherwise, we are good to wrap up.